All right, guys, thank you for taking the time to complete your notes or just to get into the beginning of our next part of our unit with this video explanation. Um, there will be some questions to go with this that we will continue to check your understanding for in class, but I'm going to go over most of the concept with this foldable, okay? So we're going to now multiply polynomials by a monomial. Monomial is one term, remember? It could be a number, it could be just a variable, or it could be a product of a number and a variable. And the thing, in order to do that, you have to remember your product rule. Now, since we are showing this little remember here, sorry, let me go ahead and start this. So since we are multiplying a to x, sorry, this x here, to the power of a, okay, times x to the b power, okay. All right, whenever we multiply with the same base, because they're both x's here, then the rules tells us that you keep that same base and you just add the exponent. So let me change my font here, sorry. So we would have this x to the a plus b. And we're going to use that rule to help us multiply um, monomials to different type of polynomials, whether it's a binomial or a trinomial or more than for a binomial. So in order to do that, you have to do, and we've done this skill before, the distributive property. You take the monomial outside the parentheses. So anytime I see parentheses right here, we should automatically be thinking our hippity hoppity distributive property. We're going to distribute this whole monomial to each term. Okay, so this is when we have to pay attention to our product rule, because right off the bat we have 3x to the second power y, right? We're going to multiply it by this first term, which is 5x to the third power. So we still do our coefficients. The 3 and the 5 gets multiplied together. Let me change my font, sorry. So that gives me 15. Then we go to the exponent. We go to our variables. Okay, kind of just go in order. So I have x squared is going to get multiplied to this x to the third power. This is when we remember to add the exponent. So this is going to be x to the fifth power. Then when we look at our next variable, the next part of our term, and that is this y here, okay, we multiply it to the same monomial, 5x to the third. Well, there's no other y here, so we just leave y in our expression. So that's the first term. Then we see here we have a subtraction sign right here, so I keep that there because I'm going to think of this as a negative 2, okay? So this now gets multiplied. This 3x squared to the y, or 3x squared y, gets multiplied to that 2xy squared. So still do your numbers together. So that's 6. Then we go to the x's. Remember, if I don't see an exponent, that's like an imaginary, or not imaginary, but invisible one. So this is now going to be x to the third power. And now when I go to my y's, because now we have a y in this other monomial, this now becomes y to the third power as well, because this is like, oh, this y on the outside is like having an exponent of 1 right there. All right, so then if we had any like terms, we can combine them. But this is our answer right here. This is it. We're just going to distribute each monomial to each term inside the parentheses, and then complete our product rule, our adding of the exponents. And that's the key. Whenever we're multiplying and we have exponents, and I'm just going to just kind of highlight this here. If we're starting with an exponent and we multiply to another exponent, that exponent should always get bigger. Okay, so that's kind of a clue to make sure you're on the right track. So that's multiplying a monomial to a binomial to 2 terms. So now we're going to continue that skill. So if you go to simplifying expressions, We're still going to do the same skill, but we're going to now have to combine like terms after to simplify it. So when I look at, change my font here, we have parentheses that lets me know I'm going to do hippity hoppity distributive property. I'm going to do it to each term inside the parentheses. So here, 3w times a negative 6w squared turns that into a negative 18w to the third power. Then I go to the next term, got a plus sign right there. 3w times 2w is going to give me 6, and that's w squared. So that's the first distributing. Then when I go to the next grouping here, I got another set of parentheses. You have to remember, if I don't see a coefficient or term in front of the parentheses, it's like that invisible 1. Okay, so we're going to distribute this negative 1 to each term. So negative 1 times 3w squared is going to leave me with a negative or minus 3w squared. Then negative 1 times positive 5 makes that now a negative 5. And then we have this plus 9 at the end. Okay, over here we have this plus 9 right here. So now all we're doing is combining like terms. And we are going to still answer or simplify our expression in standard form. That means we start with highest exponent to smallest exponent, high to low. Our highest exponent is our negative 18w to the third power. Well, then our next highest exponent is right here, the exponent of 2. So we're going to combine those like terms. And that's going to leave me with plus 3w squared. And then we have our constants, which is this negative 5. I'm going to just double underline that negative 5 plus 9. It's going to leave me with plus 4. And then this would be our simplified expression. This is a cubic trinomial, okay? Because the exponent of 3 is the highest. That's why we have a cubic, and we have 3 terms. So we're just going to really focus on you putting those skills that we have used before with distributing with monomials and with also a polynomial. Now, this last part, the area application, is just taking that skill and applying it to shapes, okay? So they want us here to find the area of the triangle. And in order to find the area of a triangle, the formula is base times the height divided by 2. Or you can think of it as 1/2 base times height. Those are the same thing. Now, hopefully we recognize that in this triangle, your base is down here, okay, where we have this 4x squared. So this is actually our B, our base. And then our height of our triangle is here, this vertical. Normally we would have a box here to prove that it's height, because height is always perpendicular. And so this 5x minus 2, that expression, is going to represent the h, the height. So what we're going to do here is we're going to substitute our parts. Let me change my font again. Instead of putting a b, I'm going to substitute that b with, substitute that b with that 4x squared. So 4x squared, and then our height, our h, was the expression, or is the expression, excuse me, 5x minus 2. Okay, and that product is all over 2. So we're going to multiply first and then take half of our result. So in order to multiply here, I'm going to have to distribute just like we did on the first 2. So when I distribute, I'm just going to show what this is going to simplify to. We're going to end up with 20x to the third power minus 8x squared. And that's going to be all over 2. So when I'm taking half of this, I'm taking half of each term. And so another way of looking at this, I'm just going to show you another way to write this. And I'm going to actually come over to the side here so I have more room. But I'm doing 20x to the third power and divide that term by 2. And then I have minus, and I have 8x squared divided by 2. So numbers are what I'm focusing on, okay? You can only simplify like terms. So this gets simplified to 10x to the third power minus 4x squared. Okay, and that is our final simplified expression for the area of that triangle. All right, so what we're going to do, basically, we're going to just practice each one of these tabs. So you needed to, I'm going to go back real quick, needed to cut on the dotted line to have each tab. And I'm going to do a couple examples with you, and then I'm going to ask you to take what we're doing together and to apply it on your own. Now, as we're doing, if you need to pause or rewind and go back, please do so. Make sure you understand the explanation. You're not just copying. I know some of you are probably copying right now, but just make sure you're listening and you're understanding why the answer and the result is what it is. So here in this first section, since we are just multiplying the binomial, they want us to make sure we answer our problem right here. It says to answer in standard form. Okay, remember that means we go from highest exponent to low. Okay, lowest exponent, or biggest to smallest. All right, so we're just going to distribute what we have, our binomial, what's outside the parentheses. So this y is going to get distributed to each term here. And so y times y is going to, if you want to see what that is, so basically we have y times y plus y times 4. Okay, you don't need to do that. I know you can do this mentally. Y times y is just going to give you y squared, or y to the second power, and then this gets simplified as 4y. So I know you can probably, some of you can go straight from multiplying to getting, to getting this answer down here, and that's fine, okay? The thing you want to do is make sure you do pay attention to your signs. So like on number 2, we have a negative 5m. So we're going to take that whole binomial and multiply it to each term. So this actually comes out to be a negative 5m to the 6th power. Remember that we have to add those exponents. And don't forget, a negative times this negative now makes this a positive. So plus 10m. Okay, and we are done. That's our simplified standard form expression. So I want you to give number 3 a try. Okay, and then we'll check your understanding in class. So I'm going to do a couple of these, not all of them, like I said, and we're going to do some more practice in class and make sure you understand. And I just want to make sure you see all types and have an explanation to go with that. So 3 is like number 2. Now 4, the only difference on 4 is now we're still taking this binomial of x, but now we're distributing, hippity hoppity, I'm showing the arrow that what I'm multiplying to each term. We're distributing to 3 terms now, so we're distributing to a trinomial. So we're doing x times x squared, that will turn into x to the 3rd power, plus now 2x squared, because x times x is x squared, and then minus 4x. Okay, minus 4x. Now, if you want to check what you got on number 3, we should end up with a negative 30g to the 4th power plus 6g cubed to the 3rd power. Okay. Now on 5, same thing. We're taking our binomial, the negative 3x to the 6th power, and we're distributing it to each term. So hippity hoppity distributive property. So this gets simplified as a negative 12x x to the 8th power, because we do 6 plus 2. A negative 3 times, don't forget that sign, that negative, that minus 5 is like a negative 5. Now it makes this positive, so plus 15 x to the 5th power. And then we're going to have a negative 27 x. Oh, I said 5th power, that should be, sorry. Let me fix that, not 5th. I make that, how do I get a 5 out of that? I apologize. That is x to the 7th power. And then negative 27 x to the 6th. Okay. Now, if you have more than one letter, okay, don't let that confuse you. You're still going to do numbers together, but do each letter at a time, but write them side by side. So I'm taking this 2ab squared and distributing to each term. I'm just drawing an arrow to point which one I'm multiplying to. Now, 2ab squared times this a squared, so the a's get added, the exponents to the a's. So this turns into 2a to the 3rd power, and you keep that b squared. Okay. Now, we go to the next term, 2ab squared times this minus ab. It's going to give me a minus 2a squared, a to the 2nd. And this is now b to the 3rd power, because if I have a 2 plus that 1, that gives me 3. And then for the last one, this would be plus 6ab to the 4th power. Okay. So I want you to take what we have done, what you have done, but what we have done on 1 through 6, and I want you to answer 7 and 8. We'll check these in class, okay? I want you to try 7 and 8 on your own. I'll have a couple questions about them just to check your understanding. But like I said, I want you to try to take what we're doing and apply it on your own so you get some independent practice. Now, we're going to simplify the expression on 9 through 12. So we're still going to distribute, but then we have to combine like terms at the end. So if I look at the first one, because I have the parentheses with the binomial 2x minus 1, I'm distributing the 3x to each term. When I do that, I'm going to have 6x squared minus, that's a 2, sorry, minus the 3x, and then I write minus 5x. And then here, hopefully you see, we have to combine like terms here, because we have a minus 5x, 3x, and a minus, sorry, 5x. So when I combine my x's, our final answer would be in standard form. Highest exponent comes first. So that would be 6x squared, and then it would be minus 8x. And then that is our simplified expression. So if you have more than one set of parentheses, like on number 10, we have the first parentheses here. We have the binomial w that we're going to distribute to each one. So we're going to do each grouping at a time. So our first one will turn into w cubed, then plus 4w squared, then minus 9w. Then when I go to the next grouping here, don't forget your sign, because this is a minus sign, so this is like a negative w. So negative w times w is going to give me a negative w squared, and that's going to give me a negative 2w. Then I go to the next grouping I have here. This set of parentheses, we have the 2 binomial that we're going to distribute. So this is going to be plus 2w minus 6. And then we have at the end this plus 9. So now what we're doing is we're combining like terms, but they want us in standard form. So we have to start with the highest exponent. Our highest exponent, sorry, is here, the 3. And there's no other w's to the 3rd power, w cubed. So we're starting off with that. Then the next highest is this 4w squared, and also minus w squared. So that's going to leave you with a total of 3w squared. Remember, we're going high to low for standard form. So the next one after that would be just the w. So I have a negative 9w, then minus 2w. That's going to leave me with a negative 11w, then plus 2w. Or you can look at these two together right here. If I were to look at just these two right here, that cancels out, becomes 0, leaving me with just that minus 9w. And then the last thing is our constants. Remember, constants always come last when we have in a standard form. So I take this negative 6 plus 9, leaves me with plus 3. And that is our final answer right here. We have a cubic polynomial, w cubed plus 3w squared minus 9w plus 3. So you want to do one at a time and then combine like terms at the end. So I do want you to try 11 and 12, okay? We'll check your understanding in class. And I'm going to go over one of the um, uh, what is it? Not algebraic, the area application problem, the geometric shapes, okay? And then I'll kind of get you started on number 14. 14 I definitely want to do with you in class to make sure you understand. But on 13, the key information they tell us is a trapezoid here. I don't know if you see that. Oops. It didn't let me show it. But a trapezoid has two bases, the top and the bottom. And it also has, because in our formula we're doing, they gave us the formula right here, 1/2 h parentheses base 1 plus base 2. And then if I'm looking at my h, I think it has it on here, but maybe not. There it is. Our h is this dotted line inside, which represents with that 6x squared. Okay. Oops, it's not showing. Why not showing? Okay, there it is. Okay, so what we're just going to do is we're just going to substitute the parts first. So if I just show the substitution, let me get the pen in the correct font. Excuse me, there, we're good. All right, so I'm just going to keep the 1/2. But now my h was represented by that 6x squared. So in parentheses, I'm going to put 6x squared. Then inside of my grouping is my b1 plus my b2, okay? Well, my b1, sorry. And the b1 and b2 can change. We can do b1 at the top and b2 in the bottom. So just make sure the bases are opposite each other and parallel. Just gotta know that part. So b1, we're writing 3x cubed minus 2x. And then we're adding that, because it said right here plus b2. And my b2 is the expression 4x squared plus 5. All of this is inside the parentheses. So what we need to do first is combine parentheses, just order of operations. We got to do what's inside the parentheses first. We need to combine any like terms that we might have. And if we look, I don't have any like terms, but we're going to put this in standard form first. So I'm just going to simplify and put in standard form. So this stays inside the parentheses as 3x cubed. But then I'm going to put now 4x squared minus 2x plus 5. And everything that we had prior outside stays. So we had a 6x cubed, and then we also had the 1/2. So the way and I probably should have done that in black, but the way there's more than one way to do this, but I think to simplify this, to make it easier, because that's what they want us to do right here, is to simplify the expression. I would do the half of the monomial first, and that's going to give you, and I'm going to change the color. This is going to give you the 3x cubed. Now I'm going to take that and we're going to distribute that to what we had inside the parentheses, which is 3x cubed plus 4x squared minus 2x plus 5. So we are distribute what's outside the parentheses to everything inside. Okay, so we got a polynomial here. So when we simplify this, and I'm going to probably write it right underneath because it looks like I'm running out of room. 3x cubed, 3 times 3 is 9, and then my x cubed times x cubed, just add those together. So that becomes 9x to the 6th power, and plus 3 times 4 is 12. This would be x to the 5th power, minus 3 times that 2 is 6. And now this is x to the 4th power, because remember it's like an invisible 1 there. 3 plus 1 is 4. And then plus 15x cubed. And then that's our simplified expression for the area. So that is just plugging in, substituting, use parentheses, and then distribute and combining like terms. So this last one is kind of complex. So that's why I'm definitely going to go over this one with you in class just to make sure everyone's on the right track with me. But you might want to go ahead and write down this key fact about shaded area. To get your shaded region or shaded area, area of the shaded region, you have to take the area of the large rectangle, the whole figure, that's what I did in yellow here, and subtract it from the area of the small rectangle. Yeah, since we both have rectangles here, the area of the large one is still going to be basically length times width. So we need to find that area, and we're going to subtract it from the area of the small rectangle, which is also a rectangle, so it's length times width. So we're going to have to end up substituting the parts in first, and then combining like terms. Well, distributing and combining like terms. So like I said, we're finished this together in class. Thank you for taking care of getting most of these problems done, getting exposed to the material before we come to class, so we can really focus on practice, practice, practice. All right. Don't forget to answer your questions and submit your Edpuzzle. All right.